In this video, we're going to be going over problems 2 and 3 from quiz 6 on improper integrals. And one of the things to pay big attention to is going to be the notation, because improper integrals always require a limit. Notice in this first problem here, I have the integral from 2 to 3 of 1 over x minus 2 squared, and I notice that 1 over x minus 2 squared here is not defined at x equals 2. Okay, we can't be dividing by 0 there. So this is the value that's making this integral improper. So I'm going to need to write this integral as a limit. So I'm going to replace that lower bound of 2 with some letter that's different from x. I'm going to choose a, but you can choose whatever letter you want as long as it's not the same as the variable we're integrating with respect to. And I'm going to have to make sure I'm approaching that value from a particular direction. Whenever we're doing those type 2 integrals, we're approaching a number, I'm going to approach it either from the left or from the right. But if it's a lower bound, I have to be approaching it from the right because I have to approach it from inside of my interval. Okay, so if I have this interval from 2 to 3, I have to be approaching 2 from values that are bigger than 2. So that's approaching it from the right-hand side. So we indicate that with this little 2 to the plus sign. So I have this limit of the integral from a to 3 of 1 over x minus 2 squared dx. Okay. So when we're doing these problems, we want to write it as a limit as the very first step. Okay. And then we can focus on doing the antiderivative here. I'm going to keep my limit notation. So I have this limit a goes to 2 from the right. The antiderivative of 1 over x minus 2 squared, well, that's the same thing as the integral of 1 over u squared, okay, because my derivative of x minus 2 would just be 1, so I'm not going to have to worry about dividing by something. So this will just be negative 1 over x minus 2 evaluated from a to 3. If you wanted to do a U-substitution, you'd have the limit as a goes to 2 from the right of this integral from a to 3 of 1 over x minus 2 squared dx. You would do u equals x minus 2, your du is dx, and then you would have to change these limits. So you'd have a limit as a goes to 2 from the right of the integral from a minus 2 to 3 minus 2, or to 1. Okay, so to a minus 2 here, and this would be 1 over u squared du. Okay, and we know that our antiderivative of 1 over u squared would be negative 1 over u, and I'd be evaluating that from a minus 2 to 1. So that's going to give us the same thing as we're going to get over here. The limit as a goes to 2 from the right of negative 1 minus negative 1 over a minus 2. Okay, so I'll just write alternate solution over here if you had wanted to use U-substitution. Okay, so notice that this was going to be negative 1 minus this, so that became plus a positive. Okay, so now we want to think about what's happening to 1 over a minus 2 as a goes to 2 from the right. Well, you can think about a graph of y equals 1 over x minus 2, if that helps you think about this a little bit. The graph of 1 over x minus 2 has a vertical asymptote here at 2, okay? And the graph looks something like this here. So as we approach 2 from the right, as we're getting closer and closer and closer to 2 here, the values are getting bigger and bigger and bigger. Okay, we can also realize that if I'm approaching 2 from the right, I'm thinking about plugging in values that are just a little bit bigger than 2. So this is going to end up being a small positive number. So if I divide 1 by a really small positive number, think of doing 1 divided by like 1 over a million, then it's like multiplying by a million. So this 1 over a minus 2 is going to be going to infinity. So I have this really big number. I'm just adding negative 1 to it, so it's going to stay infinity. Okay, so then we can say this means that our integral diverges. Okay, I saw a couple people try to use the comparison theorem on this. The thing is, the only rule that we learned before for an integral of x to the p was an integral from 1 to infinity of x to the p dx, where this converges for p greater than 1 and diverges. Whoops, this should be 1 over x to the p, not just x to the p. Okay, converged from p greater than 1 and diverged for p less than or equal to 1. So we did learn a rule about 1 over x to the p for 1 to the infinity. Okay, so some people were trying to apply it to this because we had like this 1 over u squared type thing. But the difference is, in this case, we have an integral between like 0 to 1 of 1 over x squared and not 1 to infinity. But we can't use this rule here. Okay, if I wanted to do some kind of comparison, I'd have to be able to show what happens for the integral from 0 to 1 of 1 over x squared, and then do a comparison between 1 over x squared and 1 over x minus 2 squared. Okay, sometimes the comparison test can be easier, but most of the time, if a problem doesn't tell you to use the comparison test, you're probably going to want to just evaluate the integral. And this one is not a bad antiderivative to take at all. So it's probably going to be easier and a little more straightforward to just evaluate that integral. Okay, so let's just look at this one other example here, or problem from the quiz. This is problem 3. We want to determine if the integral converges or diverges and evaluate it if it converges. This is the integral from 2 to infinity of e to the negative 3x dx. So it's improper because of this infinity. So I need to write this as a limit, replace infinity with some variable other than x. I'm going to choose b, but you can choose whatever variable you want. And this will be an integral from 2 to b of e to the negative 3x dx. Okay. Again, you can use U-substitution or not. Notice that the integral, anytime you have the integral of e to a constant times x, that antiderivative is e to the constant times x divided by the constant. Okay, so our antiderivative of e to the negative 3x will be e to the negative 3x divided by negative 3. Okay, a lot of people had times negative 3. When we're doing the derivative, we would multiply by that derivative of negative 3x. When we're doing the antiderivative, we divide by that constant. Okay, and we can only do the rule like this because it is just a constant times x. If I have e to the x squared, the antiderivative is not e to the x squared over 2x. Okay, that would be a much more complicated integral and actually one that doesn't have a rule. Okay, there's no simple way to write down the antiderivative of e to the x squared. It's actually something we can't integrate in terms of functions that we know. Okay, but if you did want to use U-substitution on this, you could use u equals negative 3x. So du is negative 3 dx. And then you'd have negative 1/3 du equals dx. That's where that divided by 3 part is going to come from. So we'd have the limit as b goes to infinity. Notice that when I'm doing these U-substitutions, the part with the limit doesn't change. B is still going to infinity, and before a was still going to 2, that part didn't change. All I changed was the bounds themselves. Okay, so this will now be an integral from negative 6 to negative 3b, changing to u limits. Okay, and this will be e to the u, and then I'll have this negative 1/3 du. So notice that we have limit as b goes to infinity. This is e to the u with negative 1/3 out in front, evaluated from negative 6 to negative 3b. So we have the limit as b goes to infinity, negative 1/3 e to the negative 3b minus e to the negative 6. Okay. You always need to be having this step where you've plugged in the bounds. And I mean your bounds in terms of the variable. In this case, in terms of b. You should never be plugging in infinity. And in the previous problem, we shouldn't be plugging in 2 anywhere. the whole issue with why something is improper is because I can't plug in that number. I have to think about a limit of what happens as I approach that value. Here, notice that as b goes to infinity, e to the negative 3b is going to 0. Okay, because this e to the negative 3b is like a limit here of 1 over e to the positive 3b. So I have 3b becoming very large. 1 over something very large is going to become very small. So notice that this becomes negative 1/3 times negative e to the negative 6, or positive 1 over 3 e to the 6. So in this case, our integral converges. So if you had trouble with this quiz, make sure to work several similar problems. You may even want to print out the blank copy of the quiz and rework the problems from that, and then look for similar problems from the old exams or from the homework to help you prepare for your exam next week. Let me know if you have any questions.